Alright, so in this video we're gonna go through some revision notes for EDEXCEL-Math IGCSE for topic 19, direct proportion and inverse proportion. So let's begin. To begin with, we need to understand what are we talking about exactly in this chapter. In this chapter we're going to be discussing proportion. There are two types of proportion in math, direct proportion and inverse proportion. Proportion is how two variables are related to each other. Any two numbers, any two variables, any two factors, but any quantity in math technically. But by our definition in the syllabus, proportion is how two variables are related to each other. In questions you might find two people, two objects, two quantities. So any two things, how they are related to each other, as long as it can be measured in a quantity. And our symbol for proportion is this symbol. It's like a alpha sort of symbol. Alright? So proportion is how two variables are related to each other. We have two types of proportion. The first one is the direct proportion. Direct proportion is telling us that as one variable goes up, the other one goes up by the same rate, maintaining a constant ratio. So, for example, the rate of evaporation. Evaporation is loss of water vapor at the surface level of water when heat is applied. And evaporation, the rate of evaporation increases with temperature. So temperature is directly proportional to evaporation, because the more temperature you add, the more the rate of evaporation increases. If you add temperature at, let's say, at a scale quantity of 5, then evaporation rate is going to increase at a scale quantity of 5. If you decrease temperature at a scale quantity of 5, evaporation rate is going to decrease at a scale quantity of 5. So directly proportional means as one variable increases, the other one also increases by the same rate. One increases, the other one increases. One increases, the other one increases by the same rate. They're parallel to each other. The graph of direct proportion is always a linear graph, which means a straight line through the origin, and the gradient is always k. So the formula of direct proportion is y is equal to k times x. This is the formula, where k is the constant of proportionality. This is what we call k in our formula. So, for example, y is equal to kx squared. K is the constant of proportionality, and y is equal to kx squared. This means y is directly proportional to the square of x. If y is equal to k square root x, y is directly proportional to the root of x. If y is directly equal to kx cubed, y is directly proportional to the cube of x. So again, in such equations where the formula is y is equal to k times x, y is always the factor that is going to be directly proportional to x, whether it's x cubed, x root, x squared, whatever the value of x is and whatever the value of y is. So again, just to complete this, directly proportional means as one factor goes up, the other one goes up by the same rate. The formula of direct proportion is y is equal to k times x. If y increases by a rate, x will increase by that same rate. To solve directly proportional questions, we have 3 steps. The first one is we identify the two variables in the question and we set up the formula using them. So for example, if a is directly proportional to b, then our two variables are a and b. And if a is directly proportional to b, then since these are the two variables, we know a is the y here and b is the x here, because a is directly with b, like how we said in the formula y is directly with x. So the formula is going to be a is equal to kb, where a is directly proportional to b. Just like how in y is equal to k root x, y is directly proportional to x. If a is directly proportional to square of b, then the formula is a is equal to k times b squared, and so on. So after you find this formula, now you substitute the value of you find k and actually substitute the given values in your question. Then you solve and then you use that formula to find the required quantity. We're going to take some examples later on. Before the examples, let's understand inverse proportion. Inverse proportion is the opposite of direct proportion. As one variable goes up, the other one goes down by the same rate. Okay, so if I suppose the rate at which I give you pens is inversely proportional to the rate at which he loses pens. So the more I give, the more he loses. Inversely proportional. As one variable goes up, the other one goes down by the same rate. So in inverse proportion, one variable is directly proportional to the reciprocal of the other, and we use the formula y is equal to k over x. And if you want to find x, x is equal to 1 over y. So inverse proportion is just the opposite of direct proportion. As one variable goes up, the other one goes down by the same rate. And to solve these questions, it's almost the same steps as the directly proportional. First, you must identify the two variables in your question. What are the two variables? And you set up the formula using them. So for example, if A is inversely proportional with B, so our two variables are A and B, and the formula is going to be A is equal to K over B. If A is inversely proportional with B squared, then our formula is going to be A is equal to K over B squared. Now you do the same thing. You find K by substituting the given values, and you use this formula that you just found to solve the equation. Now that we've understood both inverse proportion and direct proportion, we're going to take some practice questions. So this is a practice question for directly proportional. Our cost is directly proportional with the square root of time. The cost is $10 and the time is 4 hours. Find K. Okay, so first let's set up the formula. Since it's directly proportional, we know the formula is y is equal to kx. What are the values we know, or what are the variables we know? We must identify the two variables. The two variables we know is the cost and the time. The time is square root, so c is equal to k times root t. C is directly proportional to root t. Substitute the values. We know c is 10, so 10. We know time is 4, so root 4. 10 is equal to k times root 4. Isolate k, you're gonna find k is equal to 5. That's step 1 done. Or part A done. Find equation or formula or expression. To find the formula or expression, we know k is 5, so we substitute this into the original formula. C is equal to k times t, c equals equal to 5 times t, because 5 is k, this is this. And this is our equation or formula or expression. Now the c is asking us, must find the cost when time is 9. So substitute time, instead of 4, make it 9. C is equal to 5 times root 9, so C is equal to 15. Find the time when the cost is 50. So again, substitute. 50 is equal to 5 times root t. Isolate root t, take square root of each side. Time is equal to 100. Easy as that. Coming to an inversely proportional question. If v is inversely proportional with the square root of t, and v is 500, t is 64, find the formula and t when v is 1/200. So first, using the formula, we know the basic formula is y is equal to k over x, right? So here we're going to use the values v and root of t. We know v is 500, we know root of t is 64. Isolate k now. K is equal to 4,000. Substitute k into the original formula. V is equal to 4,000 divided by root t. Now that we have substituted the values, found the value of k, we substitute k back into the formula and find the value of v. So this is the formula with v. Now we need to find t if v is 1/200. So we substitute v in the new value of v inside, and we isolate t. To isolate t, first we can move it to the other side. We can take square root of each side, or square each side. Square and square root cancel each other out, so t is equal to 4,000, the value of we received for k, divided by the new value of v, 1/200. 4,000 divided by 1/200, all squared, is 100 over 9. And that's pretty much it. We have one more example here, I believe. Okay, so worked example. Y is directly proportional to the square of x. Okay, x is 3, y is 18. Find the value of y when x is equal to 4. Step 1, identify the two variables, y and x squared. Y is 18, x is 3. Since this is direct proportional, we know that the formula is y is equal to kx squared. Now we find k using 18 and when x equal 3. So 18 is equal to k times 3 squared. Isolate k is 18 over 9, the value of k is 2. Substitute the value of k into the original formula, y is equal to 2x squared, and use this formula to find y when x is equal to 4. So if x is equal to 4, 2 times 4 squared is 16, 2 times 16 is 32, y is equal to 32. And that's it for this topic.